All right, now we're going to look at ionic compounds and naming with transition metals. So keep in mind that transition metals are those in the D and F block for the most part. There are some additional ones, but the idea behind these transition metals is that they can have multiple possible charges. Multiple possible charges. Now, they're all going to be positive. So metals, the ions that they make, they're always going to be positive. So that means that they will always be at the beginning. They are cations. I'm forgetting how to spell beginning. Okay. At the beginning. And so cations are always at the beginning of an ionic compound. And when you have a metal, that metal is always going to come first. Now, when we say that metals or transition metals have multiple possible charges, there are a couple of exceptions to this rule. Silver is always +1, and zinc is always +2. So for these two, you don't even really have to do anything special. You just need to remember that those are the charges on those two particular metals. Okay, so for all of the other compounds, it was easier for me to give you the compound or give you the formula and you have to name it. With transition metals, it's actually backwards. It's easier if I give you the name and you have to give me the formula. So I'm going to show you what a name will look like if it has a transition metal. So I'm looking at copper 2 fluoride. Now notice this 2. This is the Roman numeral 2, and this is telling you the charge on the copper. Not how many coppers there are, but the charge on that copper. So if we know, okay, the copper has a +2 charge, and we know it's plus because all metals have a positive charge, and fluorine has a -1 charge based on the periodic table. It is a halogen, so fluorine always has a -1 charge. You can just do the crisscross method and determine that it's CuF2. The difficult thing is being given this and determine, oh, that's copper 2 fluoride, because many students frequently look at this and say that's copper fluoride. But that's not accurate. Since copper is a transition metal, you have to be able to tell me what its charge is specifically. Okay, let's look at another example. I'm going to look at mercury 2 oxide. Okay, mercury is Hg, and now we know what charge it has. It has a +2 charge. And oxygen is O, and it has a -2 charge. So both of these actually cancel out. I mean, we can do the crisscross method, but this is essentially telling me that one ion of mercury will cancel out one ion of oxygen. So mercury oxide is really just HgO. Okay. Now let's try and go in the reverse order. Again, I told you this way is a little bit more complicated, but I think we can work our way through. So I'm going to give you FeCl3. Now again, the first thing you're going to want to do is say, oh, that's iron chloride. However, while that's mostly correct, iron is a transition metal, so you have to give me the Roman numeral for what the charge is on that iron. Here's how we figure it out. We don't know what the charge on the iron is, but we do know what the charge on the chlorine is. Chlorine is always -1. It is a halogen. Since there are 3 of them, that's going to total a -3 charge. Well, there's only one iron, so that single iron ion has to balance out this -3 charge. So then our iron must be a +3 charge. Prove it to yourself. If you have one iron with a +3 charge and 3 chlorines, each with a -1 charge, that will result in a neutral compound. So the way you would name this is iron 3 chloride. You cannot forget about that Roman numeral, otherwise it's really not possible to determine what you are talking about specifically. Okay, let's look at another one. And in this case, I'm going to even combine it with some of the stuff that we did in the previous video. I am giving you CuSO4. Okay, now the first thing you need to make sure that you notice is that Cu is a transition metal. The second thing you need to notice is SO4 is a polyatomic ion. Okay, so we have copper with an unknown charge, and we have this polyatomic ion, and according to our polyatomic ion chart, this sulfate, well, this is sulfate, and it has a -2 charge. So now the thing to check is, how many sulfates do we have here? Well, it's only one. And how many coppers do we have? Also only one. So then this -2 charge has to be canceled out by one copper. So this copper must have a +2 charge. Okay, and the way you would name this is then copper 2 sulfate. Okay. There are many examples on your practice sheet that I highly encourage you to try and come in tomorrow and ask any questions that you have, because we're going to finish up ionic compounds tomorrow. We'll talk about some properties of ionic compounds as well. And then we have to move into covalent compounds. So make sure that you are good with this information, with this content. You know it backwards and forwards before we move on to the next step.